Hey, what's going on, guys? We're back with the next part of our Learning C# tutorial series, and today we're going to improve upon our calculation system that we did in the last episode. Just get a little fine-tuning so it's a bit nicer, and then we're going to continue on with an outcome manager, which can it's some sort of object permanence where we can check to see if we've won or lost a level, or whether we've played the level or not. And I'll explain a little bit of that as we move into it. So first thing you want to know is we're creating this new rectangle called R2, which is always going to be in this fixed position in almost the center of the screen. It's going to be the center to the right a bit and up a bit, and that's where it's going to be printed every time. I do like the idea of having it to the right and up a bit. However, I don't want it always in the center of the screen. It should be based on where our mouse is. So what we're going to do is here where we define the x value, we're going to do r dot center dot x, and then we're going to do plus 100, and then here we have our screen dot height minus 200. We're going to do the r dot center dot y minus 200, and actually I'm going to make this 100, and now we have it centered out. And I'm going to go ahead and check real quick. R equals get mouse rectangle, and you'll notice, okay, we get the mouse rectangle, and then we do all this stuff to it, and then we don't set it at the end. So just for cleanliness, we're going to go ahead and copy this and go ahead and paste it in here, just so we're making sure that we do have the center of the screen rectangle. Okay. And then we can go ahead and do time limit and mission info a little bit later. We'll have to add that into our outcome manager for object permanence later. For now, we're going to set up something simple where it just determines whether we've won or lost the level. So let's go ahead and make a new script inside of our game folder, and we're going to call this guy outcome manager. Or okay, yeah, that's what we'll call him. I was thinking along the lines of maybe calling it something along like maybe outcome permanence or something, but outcome manager is fine for now. And for this guy, we're going to go ahead and implement the Singleton implementation here. So we're going to make a public static outcome manager instance, and we'll put the stuff in there in a bit. We'll go private static outcome manager underscore instance. We need a void awake. Now, normally what we do in these awakes, and we'll do underscore instance equals this. That's what we normally do. However, this just assumes that we only have one of the script in the scene. Whereas, let's say we load up this level, we keep it permanent, we enter a new level to do our game, and then we return to the old level, which is our world map. And now we have this permanent object that survived the last time we were here, and then it's loading up the second object, which is built into the scene automatically. So what we need to do is do a check, and we'll do if underscore instance equals null. So if there's no other instance, then instance equals to this. Otherwise, destroy this. Or rather, we'll do destroy game object. So we'll destroy this game object if there's already an instance alive somewhere. Okay, and then in here we have our instance. We'll do a getter. We'll do if underscore instance equals null. Whoops. We'll do create outcome manager, and then we're going to return underscore instance. Alright, and then we'll go ahead and create this create outcome manager. Let's go ahead and clean this up a little bit. What this will do is we're just going to go ahead and create this outcome manager programmatically. So we'll make a new game object. We'll call it go. Whoops. And normally you can't just create new mono behaviors. You can create new classes as objects. However, you normally can't create new mono behaviors. You'll have to go through using another method such as add the method add component, which can add a script or a mono behavior programmatically. GameObject is another fancy tool where we can, if we use this new keyword, what it means is create a new object, which is not only a class, but it'll create the actual game object associated with that. You know, the game object meaning that it is an object in space. It has transform data, position data, all that sort of stuff. It essentially just initializes a whole game object for us to use, and assigns it to this Go variable we created. And now we can go ahead and do a go.addComponent outcome manager. And in fact, we're going to go ahead and do underscore instance equals go.outcome manager. And that reminds me, we need to go ahead and do another fix here. We'll say if instance equals null, and otherwise else if underscore instance does not equal this, then destroy ourselves. Because let's go ahead and think about this. Let's say we reference this instance for the first time and it's not there. We say underscore instance equals null, or if it's null, then create this outcome manager. Now we go ahead and create this game object. We add the instance, and so now it's no longer null. It's this guy, and everything's fine. We return that object. However, that new object has just been created. So what have I been saying that happens every time a new game object is created? This awake method is called, and now that this awake method is called, it goes, instance is not null. That's already been assigned. So we're gonna we're gonna have to destroy ourselves, which is why we had to do this second check here. We have an else if the instance is not null and it's not us, then destroy ourselves. So now it'll only destroy itself if the instance is not null and if the instance isn't itself. It wouldn't want to destroy itself that way. Okay, and now we've gone ahead, and this is the I call it the single instance Singleton implementation, and that's all we need to do. It was a little complex, but I'm going to go ahead and make a new region for this. We're going to call it Singleton implementation. And if I don't think we've talked about regions before, this is basically something for Visual Studio. It's ignored by the compiler just for cleaning up code, so we can minimize an entire region just to clean up the code a little bit. Alrighty, next thing we're going to do is let's make a new, few new properties. We'll make a public boolean, and we'll call it, actually, nullable boolean. I'll explain this in a little bit, and we'll call it one mission. Okay, so this question mark here makes this property nullable, which means that we cannot just access this with a one mission equals true. What we have to do now is a one mission dot value equals whatever. And another thing that's handy about this is we can do a one mission dot has value, which means that we can check to see if one mission is null or not. You might be thinking, like, why would that ever be null? The reason is it's going to check to see if we've won the mission or not. However, it'll do this check every time we load up the world map, and if we load it up for the first time, like if we just start the game, we've neither won or lost a mission, so we don't want to do anything. And then also we're going to go ahead and make a public string. Actually, let me do a check, real quick check here. Okay, yeah, we'll do public string. Whoops. Public string mission name. Next, okay, that's all we need for now. And now we're going to go ahead and do a public void, and we're going to call this initialize mission. Taking in a mission. And in fact, if we go ahead and open up our world app manager, sorry, here where we have this application.load level, we're going to move that and put it in here. And we're also going to do one mission dot value equals mission, or rather, not yet. We'll do mission name equals mission dot name. Okay, next is, here we have our current mission. We'll do mission dot level to load, and then from here, where we have the button, we'll do outcome manager dot instance dot initialize mission with current mission. One more thing I forgot to mention is we never actually did set up this object permanence thing. So what we have to do, it's really simple. All we have to do is don't destroy and unload game object. So now this game object will not be destroyed every time we load a level. Now if I go ahead and actually talk about this a little bit, we have our application dot load level. We have these 4 different things here. However, the only ones that are usable for us are these top 2. If you're using the free version of Unity, these 2 will actually not do anything unless you have the pro version of Unity. And I'll go ahead and talk about them a little bit too, just so you guys kind of know what they are. What load level does is it will destroy everything. It'll clean up everything in the scene, clean up all your resources, and then programmatically load the next scene. What load level additive is, I've only had to use it for games like unlimited runners, and even then I normally don't programmatically load entire levels. I'll actually load game objects into the existing level, but that's for adding loading a new level without cleaning up the current scene. So it'll load a new level on top of the current level, and then these do the same exact thing as I just explained above, except for async means in the background. So it won't, if we have a huge level, the scene will actually freeze and wait until everything loads and then load the level. Obviously we can overcome things like this by putting in a loading screen, things like that. However, if you ever played a game, a good example is like Mirror's Edge by EA. They have hidden a lot of loading times by, at the end of a level you enter an elevator, and instead of, you can still move around, you can walk, do all this sort of stuff, but it's inside the elevator. And what it does is it programmatically destroys the old scene, only the stuff that it needs to be destroyed, and then loads in the next level using an asynchronous process like this. So just a few little concepts I thought I would talk about. This video is getting kind of lengthy, so I'm going to go ahead and end it now, but we've got everything set up for object permanence now.